Hi, my name's Luke from Dotscience, and today I'm going to show you how we've plugged Dotscience into Databricks. Databricks is a great way of getting a Spark cluster on the cloud, and Dotscience is a great way of having a model development environment for AI that's fully tracked and versioned and provides metric and provenance tracking. So I've uploaded these two Jupyter notebooks into Dotscience, and you can see here that the first notebook is just going to ingest this diamonds data out of the Databricks cluster. And it's then going to version the exact data that it pulled down that can be used for later training a model. So if we go ahead and run all those cells, then you can see that we're recording the SQL statement that we use, the output file that we write it to, and a commit message, which we'll see later. So here you can see it's connected to the Spark cluster, and then we do this ds.publish, which is how Dotscience version controls everything that you do in it. So as soon as we hit save in the notebook, you can see that Dotscience is going to capture and synchronize what we just did. And then if we go into the Dotscience resources view, then you can see this new diamonds CSV data file. You can see the exact version of it that's been recorded, including that commit message. And you can see the very simple provenance chart, which at this point just says that it was ingested from Spark using this version of the code into this version of the data. So now if we go ahead and go back to Jupyter, then we can build a machine learning model. We're going to do that by reading in the file that was the output of the previous step, the file that we ingested from Databricks. And then we can see the relationship between the caret of the diamonds and the price and other features of the data, and we can look at the relationships. So to begin with, let's just start by building a linear regression model that's just a function of the caret of the diamond. And so we can see that we've gone ahead and built a scikit-learn linear regression model, and we've got a certain error rate. So normally you'd have to track that error rate manually, but with Dotscience, it makes up part of the metadata about each run. So we can go to the activity view, or the dashboard in Dotscience now, and we can see that run was captured using that exact version of the input data. And so if we go in here, we can see the provenance of the pickle file. You can see that this model is a function of running this version of the code against this version of the data, which is a function of having been ingested from Spark. And so if we go and look at all the metadata about this run, you can see the parameters like which features of the data were used and the summary statistics like the error rate. Now, that's great. What happens when we do some more data science? So suppose we go back and we overwrite the data set. So let's go back to Jupyter. And let's say that we decide that we want to just sample a subset of the data. So if we limit the data to just some of the data, and then we rerun this, then in a normal model development environment, what would happen is that this CSV file would just be overwritten. And you might make a new model with a new version of the CSV, but you wouldn't be tracking which version of the input data you used to create a certain model. But now, with Dotscience, you can see that we're recording exactly the SQL as well as the exact version of the data that was used as input to training your models. If we go ahead and rerun the linear regression, then we can see we've clearly got less data in here. And it looks like we got a much better error rate. But this is actually very misleading, because this error rate it did indeed use the same features, but the lower error rate used a different version of the data. So we can pull these two runs up side by side, one where we got the high error rate and one where we got the low error rate. And we can see that different versions of the input data were used. And so if we go and look at the input data, we can see that one run used the version which ingested some of the data, and the other run used the version which ingested all of the data. So I hope this has shown you that using Dotscience can help you track the provenance of the models that you're building down to the exact data set that was used, as well as tracking parameters and summary statistics. And that Dotscience integrates nicely with Spark and Databricks. So there's just one more thing. We've also implemented GitHub-style collaboration. So if I add Fred as a collaborator on this project, I'm going to go and log in as Fred to Dotscience. Then I can see that from Fred's perspective, I can see all of the activity and all of the metadata about this project that's just been shared with me, but I can't write to it until I fork it. So if you're familiar with GitHub, this shouldn't be surprising at all. I can now see that this project has been forked from the upstream. I could go in, I could attach some compute to this account, go ahead and make changes, and then propose a pull request back to the original author with my changes. So in this way, we make machine learning more accountable. Every change is tracked, attributed back to an author, as well as tracking the exact provenance and source of the data sets, the parameters, and the models that were used in developing models for production. Thanks for watching.